All right, so last section of the first um, unit, we're going to do a quick introduction to the periodic table. We're going to talk way more about the periodic table. This is just kind of a quick introduction, and you're going to have to memorize the first 92 elements, name and symbol, that's it. No numbers or anything, just name and symbol. That way, if I start talking about nitrogen or cobalt or something, you don't have to be like, oh no, what element is this or whatever. I just want you to be able to know. So most element symbols consist of the first letter of the name. So N is for nitrogen. Sometimes you'll have Greek or Latin names. Those are very noticeable as you go down, and we'll talk about those. But if there's more than one letter, you capitalize the first letter, and the second letter is lowercase. Now, this is very important. Okay, you can't, don't mess this up. Because, for instance, cobalt is a great example. If you have capital C, capital O, well, now you have carbon monoxide. Very different from cobalt, very different. So it's very important that you pay attention to that rule. Second letter, always lowercase, first letter, capital. The atomic number is the number of protons, and that number is typically the number in one of the corners of the square in the periodic table. That's the number that they're ordered by. They are ordered by atomic number of protons, and this is what makes one element different from another. You can have different elements with the same mass because they have different atomic numbers. They are in fact different. So if you want to change the identity of something, you have to change the number of protons that it has. We talked about that. So a periodic table, and notice I said a periodic table. There are different periodic tables. The one we use is the most common one, and I think the best, but other people have other opinions maybe. It's an arrangement of elements, and the elements are separated into groups based on a set of repeating properties. They periodically repeat. So you can compare these properties easily because the columns, there's the bell, no one's here, there's the columns are families or groups, and they have the same properties. So for instance, sodium and potassium act similarly. So you kind of go down the row, and then when you get back to potassium, you have the same column again. So it periodically repeats with the properties. The horizontal rows are called periods, and there are 7 of those. And within a given period, the properties vary. So there's really, we'll talk about orbitals as time goes on, but other than that, there's not much in common, especially in terms of properties as far as across a period goes. So here's what the periodic table looks like. The number in the corner, like I said, is the atomic number. The number below the name is the mass, atomic mass. And you have the symbol and the name. A lot of them will just have the symbol, they won't have the name. So that's another reason why you need to know the symbol. The columns, like I said, can be called groups or families. There are 18 groups, and they do have similar properties within the same group. There are 2 main sections, metals and nonmetals. There are a lot less nonmetals than metals. The metals are on the left side, the nonmetals are on the right, and then some right there on what I call the stair step are called metalloids. So right here, the green ones, those would be your metalloids. To the right of the green ones would be your nonmetals. To the left of the green ones would be your metals. So notice there are a ton more metals than there are nonmetals. Those are the 3 main groups. We'll talk about other groups as time goes on. Across a period, elements become less and less metallic and more non-metallic. So you start off on the left here, like with sodium, potassium, lithium, all those are very metallic. And as you progress toward what we call the noble gases over here, which we'll talk in a second, you become less and less metallic. Metals are good conductors of heat and electric current, which you probably already knew. 80% of the elements are metals, and they typically have high luster, are ductile, and malleable. So you can make them into sheets or string it into wires, make wires out of them. Couple examples, probably all already know about that. Nonmetals are typically poor conductors of heat and electric current. Most nonmetals are gases at room temperature. A few are solids. Sulfur and phosphorus are examples. One nonmetal is a dark red liquid. That would be bromine. It's nasty stuff. Dealt with that before. A metalloid, so the semi-metals, metalloids, semiconductors, all the same thing, the green ones. They have properties that are similar to both sides. They're kind of like right in the middle, and their behavior can be controlled by changing the conditions. So if you want it to act more like a metal, you can have a certain set of conditions. If you want it to act more like a non-metal, you can change those conditions. Boron, when it's mixed with silicon in a small amount, it's a good conductor of electric current, and silicon can be cut into wafers, and we use them as computer chips. So that's why you get Silicon Valley. Noble gases are group 18. So when we go back here, over here, group 18, helium, neon, argon, krypton, xenon, radon. Those are your noble gases. They are generally unreactive in gases at room temperature. They're used in neon lights. Now they're all called neon lights, but that's sort of like Kleenex, you know. They had a neon light, then they started using the other noble gases, and they just all were called neon lights. But helium obviously is used in party balloons and weather balloons. It's less dense, so it floats. And yeah, I think that's really all we got. Hopefully you learned a lot in that unit. And if you have any questions, please let me know.